everybody. Today we will discuss the zero order reaction. So zero order reaction means the rate of a reaction does not depend upon the concentration of the reactant. So one of the example is the photochemical reaction in which the rate of a reaction is depend only on the intensity of the light. See here I have shown the picture of a photosynthesis in which the photosynthesis will occur only in the presence of the light, sunlight. Otherwise, it does not occur. So, how we will write the rate expression for zero order reaction? So, consider the reaction A gives product. So, the rate is equal to minus dA divided by dt, that's equal to K into concentration of A to the power 0. That means minus dA by dt, that's equal to K only. So if we are representing in terms of x, dx by dt, that's equal to K. So dx is equal to K into dt. If you are doing the integration, integral dx is equal to K into integral dt. So integral dx is equal to x and integral dt is equal to t. So x is equal to kt, K is equal to x by t. Then what about the half-life period of the zero order reaction? Half-life period T half is equal to, first of all, you should write the integrated rate expression for the the zero order reaction. K is equal to x by t. So after that we have to substitute x is equal to a by 2. So K is equal to a by 2 into T half. So T half is equal to a by 2K. So here T half is directly proportional to the concentration of the reactant in zero order reaction. In first order reaction, half-life period is independent of the reactant concentration, and second and third and nth order reaction are inversely proportional to the reactant concentration, and only the zero order reaction is directly proportional to the half-life period. Now we are moving into the general characteristic of zero order reaction. So every zero order reaction obey the integrated rate equation, and all the zero order reaction is independent of the concentration of the reactant, and the unit for the zero order reaction is mole, liter inverse, second inverse, and half-life period is directly proportional to the initial concentration of the reaction. Then how we will plot the graph of the zero order reaction? For plotting the graph, see here, first of all we should write the rate expression for the zero order reaction. K is equal to x by t. So instead of x we can write a minus x. Then we know that the equation for the straight line y is equal to mx plus c. So while we are comparing this equation to the straight line, x coordinate is t and y coordinate is a minus x, and the slope is minus k and the intercept is a. Now there are some examples for the zero order reaction. First one is the thermal decomposition of Hi on gold surface. So the 2 mole of hydrogen iodide in presence of gold as the gold and heat, it will decomposes to form hydrogen and iodine. So corresponding rate is equal to K into concentration of Hi to the power 0. So similarly the thermal decomposition of N2O on platinum surface. N2O in presence of platinum and heat, it will decomposes to form the nitrogen and oxygen. Here also the rate is equal to K into N2O to the power 0. Now we are moving into the nth order reaction. Nth order reaction means any reaction in which there are n number of molecules are involved So how we will represent the nth order reaction? Na gives product. So how we will represent the rate? Rate is equal to minus dA minus x by dt, that's equal to k into a minus x whole square. Sorry, a minus x whole to the power n. So dx by dt is equal to k into a minus x to the power n. We have to move the a minus x raised to the power n term to the left hand side and dt to the right hand side. So our equation become dx by a minus x whole to the power n, that's equal to k into dt. If you are integrating, our equation become integral dx by a minus x whole square, that's equal to k into dt. So our final integrated rate expression for the zero order reaction is equal to k is equal to 1 by t into n minus 1 into 1 by a minus x whole to the power n minus 1 minus 1 by a to the power n minus 1. Now we are moving into the half-life period. So according to the half-life period, first of all we have to write the integrated rate expression for the nth order reaction. After that we have to substitute x is equal to a by 2. Then after rearrangement we can see that T half is inversely proportional to the initial concentration. T half is equal to 2 to the power n minus 1 minus 1 divided by k into n minus 1 into a to the power n minus 1. That means T half is inversely proportional to the initial concentration. Now we are moving into the general characteristics of the nth order reaction. All the nth order reaction is independent of the all the nth order reaction is depend upon the initial concentration of the reactant molecule, and all the nth order reaction must obey the integrated rate expression, and the unit of the K for the nth order reaction is mol liter raised to minus 1 whole to the power 1 minus n and second inverse, and half-life period is inversely proportional to the initial concentration of the reactant. Thank you.